Hi, welcome to my video on simplifying square root radicals. Which method is better? The greatest perfect square or the prime factorization when you're trying to simplify a radical? Well, let's see if we can explain. The greatest perfect square method is faster if you can find the greatest perfect square. Faster if the number or radicand is not too high. Prime factorization is slower but is more effective on a large number. Let's do some examples to explain. Simplify each as a radical using one of the methods. I have the square root of 8. So, square root of 8, that's 4 times 2. So that's 2 root 2. Square root of 4 is 2. So I'm doing it faster now that I have did all the work, showing you all the steps. So once you put the perfect square down as 4 times 2, square root of 4 is 2, and this 2 stays. So prime, this is, because I picked up the 4, I would do the smaller numbers with the perfect square. 18, the perfect square as a factor in 18 is 9 times 2. And the square root of 9 is 3 root 2. Again, I can see the perfect square. Now, in 112, if you can't see the perfect square, then I would go with the prime factorization. As an example, I would say 2 divided into 112 because it's even. 2 into 11 is 5, 1 left over. 2 into 12 is 6. Again, it's even. So 2 into 56 goes 28. It's still even, so divide by 2 again, 14. It's still even, so divide by 2 again, I get a 7. So 112 is made up of 2 times 2 times 2 times 2 times 7. So there's 2 2's, you take 1. There's 2 more 2's, so you take that 2. And the 7 is left, so you get a 4 root 7. So would you have come up with the perfect square of 16? Because 16 times 7 makes 112, but would you get the 16? So prime factorization might be a little bit faster. And 294, what is the prime factorization? Again, or what is the square root simplified? I would do the prime factorization. So again, it's even, so I would divide by 2. 2 into 2 goes once, 2 into 9 goes 4, 2 into 14 goes 7. And it's not even, so let's see, add up 1, 5, 12. Since the digits add up to 12, 12, that means is divisible by 3. The digits adds up to be a multiple of 3 and is divisible by 3. 3 into 12 goes 4, and 2 left over, so 3 into 27 goes 9. And 9 is 7 times 7. So that would be 2 times 3 times 7 times 7. So there's 2 7's, so it's 7 root 6. Again, would you know that 49, if you could get 49 times, that's 49 there, 6. So if you can get 49 right away times 6, then you would have had 7 root 6. But not likely to get the 49 right away. So prime factorization is, again, I think, better when you have larger numbers. When you have smaller numbers, I would use the perfect square. Large numbers, I would use prime factorization. So practice means pause the video, work each of these out one at a time, press playback, and see if you're going to get it right. 28. I would use the perfect square because 28 is made up of 4 times 7. Square root of 4 is 2, so this 2 is out, 7 stays. I wouldn't use prime factorization. 75 again is 25 times 3. Square root of 25 is 5, and root 3. 63, the digits adds up to 9, so that's 9 times 7 9s are 63. So square root of 9 is 3, so that's 3 root 7. Now they're getting a little bit bigger, so you could take a chance and say 25 is a perfect square here. And if you take the calculator and go 175 divided by 25, you get a 7. So if you did the perfect square here, taking a chance that 25 is the perfect square factor of this, then you would have been right. You get 5 root 7. But if you did the prime factorization, you would have gotten 5. Because it ends in a 5, 5 is a factor. So 175 divided by 5, 5 into 17 goes 3, 5 into 25 goes 5. Again, 5 is a factor, 5 into 35 goes 7. So you would have had 5 times 7, which is 2 5s. You take 5 out and a 7 stays. So it's your choice. But what about 726? Now that's a large number. Can you get the perfect squares here? I wouldn't risk it. So I'm going to work it out by the prime factorization. And why? Because it's even. I divide 2 into 7 to get a 3. 1 left over. 2 into 12 goes 6. And 2 into 6 goes 3. Now adds up to, I see a 3 and so I will divide by 3. 3 into 3 goes once, 3 into 6 goes 2, 3 into 3 goes once. And a 121 is made up of 11 times 11. So it's 2 times 3 times 11 times 11. There's 2 11s, so we take 1 out. And the 2 3 stays, so 2 times 3 is 6. So would you have gotten 121 as a perfect square? Not likely. So prime factorization. And look at this number. Number 6, 1053. Again, I would do the prime factorization. You add up the digits, not even. Add them up. 8 plus 1 is 9. That means it's divisible because the digits adds up to be a multiple of 9. 9 will go into 1053. And 9 into 10 goes 1. 9 into 15 goes 1. And 9 into 63 goes 7. And again, add them up. It's not even, so add up the digits. You have a 1 plus 1 is 2, 7. Adds up to be a 9. Again, is divisible by 9. 9 into 11 goes once, and 2 left over. 9 to 27 goes 13. So, if you have a 9 times a 9 times 13. So I got 2 9s, so I take a 9 out and 13 in. And notice 9 9s are 81. So would you pick 81 to be the greatest perfect square factor of this? So prime factorization again. So if a number is small, probably perfect squares. If a number is large, use prime factorization. That brings us to the end of the video on which method is better, your choice. And if you like the video, click the like button, click the subscribe button and notification bell because there are more videos coming your way. Write a comment on my video if you wish. And visit my math website, www.mathfullyexplained.com. And the section on me talks about my degrees and teaching experience. The video section talks about the strategies I'm going to use to help you learn your math. And the content section has the topics and the number of videos on those topics on my YouTube channel, Math Fully Explained. The black font is what's online right now, and the red font is the topics that will be there in the near future. Thank you very much. Bye-bye.